Thank you very much for attending this session. It's an interesting topic. It's one that Andrew covered a couple of years ago in person, but there have been some significant developments since then, and I guess more people will be finding a requirement to do this more seriously. So it's an absolutely excellent time to revisit the subject and look at some major changes. One of which I personally find very interesting, which is the idea of using a separate HSM just to do Unix file backup, which Andrew has promised that he'll be covering in the session. So as far as questions are concerned, please use the chat window to enter your questions, and Andrew will get to them at the end, assuming you don't have 2 hours worth of slides.
Hope not. I don't think so.
So with that, I'll hand over to Andrew. Thanks very much, Andrew.
Great, thank you, Nigel. So good afternoon. I think it's afternoon in England or Europe over there. So I'm calling from Tucson, Arizona. So it's still 7 a.m. in the morning for me. So hopefully the kids are getting off to school okay, and the session goes well. So today I'm going to talk about the Unix file backup processing in HSM and all the new things that have been added since we last joined or last talked to you about it. So last time in 2019, I came and spoke. We had just released this OA 52703 APAR, so on 2.3 and 2.4 and above, and so it lets you back up Unix files using HSM and keep them in the HSM inventory, and tried to add a lot of useful features where you could back up all the directories and the files in a directory, all the files in a directory subtree, so that you could manage how you're backing things up however you wanted to. So some interesting things that I included that I don't see people using very much. Specifically that you can select files that are included in the backup. So you can have a file name pattern on the request, and as we're looking at all the files in the directories and the subdirectories, we'll only back up files with those pattern. But I'm finding that people don't use that very much. I'm not sure if they're used to the old TSM product, which didn't do that, or why. But we did also add the support to have exclude criteria, so that you could exclude files based on some pattern, and that came a little bit later in a follow-on APAR as OA 57868, and also in that you can exclude directories as well. So this support by default only does incremental processing. Well, that's the default. If you want to, you can say you want to take a new backup of files even though there's an existing backup. I don't know why that's like that. And in the support, we included something that's called ZFS file snapshot. I shoehorned that in with the HSM concurrent copy keywords. So it provides a similar function that lets us get serialization on a file and then release it very quickly before the backup is done. And then our backup is done from that snapshot and not from the existing file. So that allows your applications to start open that file for write very quickly, even before the backup is done. And then we have this thing, we called it recursion, which is the directory subdirectory processing. So, and very important, I did want to point out the fixcat keyword, this Unix file backup /k. So as we've been working, we have follow-on continuous delivery APARs. We always tag them with this Unix file backup, and any APARs or defects that have been found, we also tag them. So definitely keep current with any of those as much as you can. So with the support, I shipped new Unix shell programs, so kind of figured we're backing up Unix files, so we might as well be able to have a Unix program that backs up Unix files as well, instead of the existing operator commands and TSO commands. So here is showing this HBackup program with some options, the operator mode option and the recurse into subdirectories, but don't cross mount points, of the /u/user2 directory. And I'm trying to show the underlying ZFS type directory structure. Well, ZFS, the data sets that are holding the files and directories. So in the /u directory, here's user1 directory that has this auto-mounted file system, and then user2, and it's showing the ARC1000i messages showing the files that it backed up. So it backed up the file1 that's directly there, and then it recursed into the dir1 directory, found the file1 there, and file2 into dir2, and also this empty directory. So you notice that it did not go into the loc B directory because that is the mount point for another file system. So this -X option means recurse but don't cross mount points. So my rationale for including that was, many shops like to back up things at a ZFS level, or they may want to take backups at a ZFS level. So some ZFSs have more changes, maybe like this ZFS.prod production ZFS, and so they want to take daily backups of it, but the user directories, they only want to take weekly backups. So this would allow them to back up things, as they wanted. Later I found out that a lot of existing TSM users just use the DSMC-I and of root, and so they say just look at the entire file system and back up anything that's changed. So you can do that too if you want. So on this, just wanted to show this HBackup program in the Unix. Has some options, -C for the changed only type processing, which is the default. D is to delete files after they've been backed up. So that was, we had a requirement where they wanted a equivalent to the archive type processing with delete files from the TSM product. So the -D allows you to delete the files after a backup has been taken, and it gives them a retained days of 1 year by default. -X and -R, that's the recurse no cross mounts and recurse cross mounts. There's verbose, no wait processing, and then a quiet mode. So if you're familiar with HSM dataset backup, a lot of these may seem familiar. There's the target, new file names. If you want to give as you're taking a backup of some existing files, but you want to import it into HSM as a different name, you could use the N for that. -R is for retained days. The exclude criteria is on the command there. The date and time, that goes with the new name, and then the CC options, and then the -P, these are the number of Unix side processes for managing the backups. So that's really only useful if you are giving multiple directories or multiple names to this Unix backup. So here you can see this one backup command, you can pass multiple files in a directory and whatever. And then the kind of secret option of -O is the operator mode. It's what was going through my mind at the time. And it's basically like this this hbackup command is essentially a user command, similar to the TSO hbackds command. But if you're a storage administrator and you want to use the Unix program to do your operator or storage administrator type backups, you can add the -o option. And so that turns it into an operator command, which is just like doing an hsend backds. And one of the nice things about the hbackup program and all these Unix programs is that they send all their output and their messages to standard out. And so if you're running it in batch and executing this program via bpx batch or something, you can capture all the files that were backed up, all the successful messages, all the unsuccessful messages. Different from hsend backds, all those messages will be sent to the TSO. If you're running it in batch, it'll be sent to the TSO user ID that issued the batch, and so you don't get to keep the messages as well. I also introduced an HList, a Unix program that's called HList. And so here's a little example of it. It has the same options as the TSO HList program does, with the age, max age, min age, you can select what you want. You can see the manual for those, but it gives you the output that you're used to seeing, with the exception of, as we're going into subdirectories, as we're looking at the HSM inventory and we're looking at subdirectories, it will put out this dir, the current directory that it's looking in. So sometimes we might have a directory, but there's no file backups within that, and it was difficult for some of the users to figure out where we were in the HSM inventory. So they asked that we add this kind of title that, we're in this user2 directory. So this is just a single request of list the files that are in the user2 directory. So there's no recursion, that -x or -r option. And here's the file, and then the backup copy data, the backup where the backup is, the data set where the backup is contained in. So here it's this dfhsm.back.file name, which volume it's on, etc. Here's a little bigger one, kind of showing as it recurses into subdirectories. It gives you the directory level, and then here's the subdirectory as it's going in. So we also added a hrecover command. So if you or users want to recover their own directories or their own files, they can. Gives us some options, and one follow-on request that we had, kind of new since last time I talked with you guys, is the new directory. So you can request HSM recover a bunch of files, but put them in a different directory that they were backed up from. So that way you don't have to step on what is currently there. And like before, I mentioned the -o says run this as like a storage administrator. I do want to point out that if you specify the -o option, we do check the storage administrator facility class for that to see if your user ID has read permission to that, in this example, the recover facility class. And if you do, then it'll run it as an operator, or without checking the individual permissions for each file. So, but if you have some user that does not have read access to the storage administrator facility class, then we'll fail the request right away. So normal users can't ask to recover things at the operator level. And the last Unix program we added was the bdelete type program. So you can delete backups if you need to, all of them. -a is all backups for a particular file or certain versions or a date and time backup. And it does have an operator version so that you can, as a storage administrator, you can delete backups. Otherwise, we check the user's permission to that file, and if they have permission to write to that file, or they're the owner of that file, then they can delete the backup. And I did want to point out that there is no directory level or recursive processing for the hbdelete command. So that was mainly, I did not want to get a sub1 PMR or case where someone's saying, help, I just deleted all of the backups for my entire system. What do I do? Because I had delete recursive processing. Okay, moving on. So as part of the support, we did update all the storage administrator commands. So backds, you can use those, but those have the requirement that the directory or file that you're requesting for the request must be an absolute path. So if you have a very long directory name, then you have to type out the exceedingly long name there. And if you're putting it into batch JCL or something, you have to do some tricks to have such a long name. So that's not that usable for a lot of things. The Unix programs all accept relative paths, so you could give it an absolute path, but you could give it a relative to your current directory path. In addition, we did update the audit command and the query, cancel, and alter commands so that you can get information or audit information about the Unix file processing. The TSO commands were also updated, so you can check those out if you want. Okay, so since Nigel brought it up, I did want to talk a little bit about the file mode host support. So after we released the initial support, I had a couple customers say, like my current HSM is just super busy. It runs almost 24/7 just doing the dataset level type things, migrating and doing space management and the backups, and just don't have the bandwidth in my current HSM Plex to handle this. So I shipped this support in OA 58870 that lets you have two unique HSM plexes on the same ZOS LPAR. So, and this, I named them, one is the classic HSM and the other is a file mode HSM. So these guys have their own control data sets, and the logs and journals and trace data sets, they're all completely separate. So that's pretty good, I think, because then it allows your file mode HSM to have its own backup control data set, which probably could be quite large if you have a lot of Unix files you need to back up. And it won't interfere or get involved with your data set processing. So basically you segregate your Unix file backup processing to that other address space and its control data sets. So here's kind of a picture of what it could look like in a, I guess, small system. And I was imagining the existing environment was on a system A and a system B, and they currently had this, what I'm in blue, this HSM classic host. So after they have implemented the file mode HSM, as part of that, you need to take your existing HSM and change it into a classic HSM. And so that really doesn't mean a lot. It just is saying that the existing HSM only does dataset level type processing, and it will not have anything to do with Unix files if a request comes in for those. So mainly that's a backup request. The classic HSM will fail those and say, I don't do that. You need to go talk to the other HSM. So after they implemented it, they said host type equals classic. So this is on the proclib startup member for the HSM. So here's host 1, host ID 1, and host ID 2. And it was originally it was a primary. There on this system they had a main, or each one was just a main, and implemented it as a classic. And then they wanted to have the HSM, the file mode HSM, so they spun up, or they had a small LPAR on the side. It wasn't doing very much, and so they thought that was a good place to put their main file mode host. And so they gave it a host ID of Z, because they could have given it a host ID of 1, so the host IDs can be the same between the different hosts, but it doesn't. They don't interfere with each other. So I just, for this example, thought I'd use different letters. So on the system C, they have it's the primary host, and they also spun it up as the main. And the file mode host support also supports the multiple address space HSM, the MASH stuff. So you can have auxiliary hosts on a system that are in the file mode HSMplex. So then I was also showing here is an X, host ID X and host ID Y, and they're both secondaries, but on each system they're just mains. And let's see, I don't think I have much. Oh yes, I did. Okay, good. So I did want to talk a little bit about the configuration of the file mode host. So in the DFSMS implementation and customization guide, I added a new chapter. It talks all about the changes and steps you need to go through to do that. I'm going to go off script just really quick. See if I can show you guys this. And let me get to, not the diagnosis, implementation and customization guide. In the implementation, implementing HSM. Here, DFSMS HSM in a multiple image environment. And so in there is, there it is, creating a DFHSM host to process only Unix files. So here is some description of that, and then the next chapter after that has a kind of walkthrough of how to do the conversion from it. So, in short, in your proclib member, or that's a typo there. So they have host type equals classic for your existing host, and then host type equals file for the new one. And so basically walks through those steps to do that. As part of this support, I added some new commands, and basically they're the existing commands, except they have a U on the end. So for the Unix host, so hsendu is the command that you would use to send storage administrator commands to the file mode host. So if you want to tell the HSM, the file mode host, to do expire backup volume processing, you could just say hsendu expire BV and whatever options you need to. And then the hsend command sends the whatever command to the classic host. So the TSO commands all have U versions now as well, so they can kind of have a pretty clear idea about, yes, I know I'm talking to the file mode host. In the file mode host, I made many of the functions. Actually, most of the functions are held permanently. So there's not even a chance of the file mode host trying to start automatic or primary space management or secondary space management. The auto backup processing for the file mode host is not held, but it only does the first two phases. So phase one is where the control data sets and that stuff is backed up. And then the second phase is where backups that are on the ML1, the DASD, are moved to the daily spill volume, so are moved out to tape, and then the auto backup is done. So it's good to still have your automatic backup scheduled for the file mode host, but you don't. It's not going to try and back up any data sets. So other things, dump, FR backup, that's all held, and if you try to release it, it'll tell you it's not going to be released. If you do send a backvol command for a volume to the file mode host, it'll just fail it with an error message saying, this is a file mode host, I don't do data sets. Likewise, if you send a backds command to the classic host for a Unix file, it'll fail that and say, I don't process Unix files. And then last, I wanted to mention about the activity logs. So if you're using activity logs on DASD or tape, the name of the activity log is slightly modified. So we still, if you're patching that MCBT activity log name, so we'll still use that, but in the classic host, it's just H with the host ID. But for all the Unix hosts, it's HU with the host ID. So here's an example. It's, for the backup log, it's the file mode host on that. Okay. Good. All right. Well, and if you have questions about the file mode hosts, we can type them into the chat and get to them at the end. I do plan to show you the file mode host I have running on my small VM system. Okay, recently, when did this go out? Just recently this year, I think it was in August. Another follow-on support, this OA61080, went out, and it introduced a Java program. I called it Java, H backup program for Java. But what it does is it offloads this file examination work to the Java program. So if you issue the Unix H backup program or hsend backds of a directory, all of the examination of the directories and subdirectories, that's all done within the HSM host. So in the ARC control address space. So once the original support went out, we were noticing there was quite a bit of CPU usage just of the HSM address space looking at the files to be backed up. So, and as is looking at each directory and each subdirectory and looking at each file, and it would take quite a while to do it and use a fair amount of CPU to do it as well. So this follow-on APAR, DAPAR, we shipped it on 2.3 and above. It introduced this Java program, and so all that examination work is done in the Java program. So that allows you to utilize any zips that you have, or just get that processing out of the HSM address space. And then any files that it finds that are in need of a backup, it will then send those over to the HSM address space for the actual backup. So it seems like it works pretty good. As part of this new support, I added some new options that don't exist for the Unix program or elsewhere. Added a -- test option, and my idea for that was, as you are looking at a directory, you're wanting to find out what would be backed up, what may be excluded as part of the exclude criteria, that type of information. But you don't want HSM to actually take a backup of these. You're just trying things out. You can add this -- test, and it will just tell you I found this one, it needs a backup, and I found this one, it wasn't changed. I found this one, it's an unsupported file type. I found this one, it's been excluded, all that kind of stuff. And I also found that I was kind of dissatisfied with the verbose output level in the Unix program. So I wanted to have a little bit of finer granularity for the verbose output level. So this -v with a level on it will give you these different levels. Stat for statistics, which is these ARC577 messages, which tells you how many files it excluded, how many files that it matched up with, and then how many it actually sent to HSM, and then also a runtime of that Java program as it took to look at all the files and wait for HSM to finish backing up the files. The detail level tells you details about each file that it found. The times level gives you timestamps on all the messages, and then the all tells you what options were on the command and everything that I could possibly put out. And last, I wasn't very happy with the existing exclude criteria, and also we had a lot of requests for being able to specify the exclude criteria in a file. So this Java program supports that, and it additionally added this // type syntax, which is a wildcard for directories. So you can, I'll show an example later, but you can say, I don't want to back up anything in any logs directory. And so you would use this directory wildcard for any number of directories, down to a logs directory. I want to exclude it. So hopefully that is helpful for people. And this, I don't think the pub updates have made it to the online pubs yet. So you can go to this website to read more about it. Let me go over there. Oh boy, this thing's in the way. So, and this is what it looks like. So pretty soon we should have the updates for this, but this will tell you all about how to set your class path and your lib path to be set to utilize the new Java program. And in here is a quick description, or where I'm using the detailed verbose output level of a backup request. So here is showing 578. Here's a file that was unchanged. Here's a file that was excluded, excluded unchanged. And then the statistics says I excluded 38 files. There's mount points directories, so because it was a -X. How many files matched, and then out of those, how many files matched. Some of them were unchanged, so they didn't get sent to HSM. So that's why the matched and files sent to HSM is 78. And so all that processing to look at all those files took 2.7 seconds on my virtual machine. Okay, so back to the mainline type thing. Just wanted to note some things for you. If you're using, the Unix file backup processing is all command level type stuff. And so for HSM, that means that it targets the ML1 volumes if you're going to DASD. And so if you're going to tape, it won't go to the ML1 volumes. But so if you do a -T of DASD, then it'll send them to your ML1 DASD volume, and then the automatic backup processing will move those backups to the daily backup volumes. The HSM tasking level makes a big difference on the speed at which HSM processes all these files. So the more tasks you feel comfortable assigning to HSM, the better. So in this case, the setsys DS backup is what controls that. So in DS backup, there's a DASD, tasks 14, tape, tasks 4. And so that means there's 14 DASD tasks that it can use and another 4 tasks that go to tape that it can use. The backup versions option in the setsys parmline member tells HSM how many versions of a Unix file backup to keep, as long as it's from a non-SMS ZFS dataset. So I'll talk about that in a little bit, a couple slides. And then last, the backup copy, the dataset name that the backup copy is placed in, uses the new-ish HSM format. I think it's 10, 12 years old, but where it's the hundredths of seconds. So the CCCC is the hundredths of seconds in the current hour. So that's a timestamp with the last directory and the 8 characters from the file name of that was backed up. Okay, so for management of the backup versions, it really depends on if the ZFS that contains these Unix files are SMS or non-SMS. And so if they're SMS managed, then we will look at the backup attributes from the management class. So here in this example, it has number of backup versions is 2. And so for a Unix file, when we take a backup, as if there are 2 current backup versions and we now have a new version, we will keep the newest version and then roll off the oldest one. And then the number of backup versions, dataset deleted, that's used during expire backup volume processing. And so earlier at the first slide, I talked about the ZFS file snapshot. And so this is basically, we keep the serialization only as long as we needed to take this snapshot, and then we drop the serialization. So it's similar to the idea of the concurrent copy, where we serialize the data set, and then as soon as we have the concurrent copy done, then we release the serialization, and then we continue with the backup from that concurrent copy. So this ZFS file snapshot is the same concept. So if it does have some caveats, it must be done either on the owning system, so the system that owns that ZFS, or if the ZFS is mounted read-write share, then it can be done on any system. So the read-write share status is very important if you're using that. And just a note, make sure you have this OA61711 APAR from DSS if you're using any of this stuff. So they found a bad problem there. Okay, let me go back. Okay, for facility class checking, I'll go pretty quickly. But so your existing environments, whatever facility classes you have set up, this applies to all the Unix processing, Unix file processing. So, and for the Unix programs, we also tied those into the existing user levels type stuff. So if you want to keep your users out of doing Unix file backups, you can just use the existing type stuff. I did have some concern from some storage administrators about the -R, so that means cross mount points. So go into subdirectories and go into ZFSs, as you cross mount points. And so some storage administrators said, I'm not going to allow normal users to do that type of big processing. So, but they might allow the no cross mounts type processing so that they could back up their own directories. And the function statistic records, if you gather these and you look at them later, just want to note that the hex 40 bit at this offset is a bit that says this FSR is for a Unix file. Another way to tell is that the volsir will always be this %Unix %. So hope that was a clever thing and not a stupid thing, but I don't think that's a valid false here. And then in the FSR DSN field, so that's the 44 character dataset name field, we use this shortened Unix file name, which has the first part of the directory with ... and then the last part of that absolute path. So, but if you want the full file name, it's at the end of the FSR after any tape volume entries. So, quick thing there. After the initial support, we also needed to make some changes so that we could, the dcollect and arcutil programs, or idcam's dcollect, could gather information for the Unix file backup. So that was in APAR OA59510. So there's some new keywords. Instead of just BACK for the dataset backup information, and we have backup U, which says give me only Unix file backup information, or I want all backup information. And likewise, the full file name is at the end of the record. So I did have to do some funny yoga poses to fit these Unix file stuff in with what we had for datasets. Datasets only 44 characters. Unix files, well, it could be anything up to 1024. So good luck. Okay, so if you're a current user of the old TSM product, Spectrum Protect, and you want to start using HSM for your backups, you could look in the log for any directories and files that they have scheduled for backup. You can do a DSMC query with this syntax to find what backups do they have. Another option, if you find that they're currently doing DSMC backup of /dir1/* the equivalent HSM for that would be hbackup with -o and then double quotes around /dir1/*. So the double quotes are important because the Unix shell will try to help you and expand out that asterisk to be just the files or directories it finds in that directory. So if you want HSM to do the actual looking, you need to just use double quotes and to pass this statement or this text directly to HSM. Another thing I mentioned earlier, because I found people just had DSMC-I of root, and so if you want to do that, this command would use the dsmc.opt file for the exclude criteria that TSM was using, and so the equivalent today for that is the hbackup program -o for operator mode, -R for recurse crossing mount points, and then the exclude criteria is on the command here, and then specifying / as the directory. The archive, here's the DSMC archive with delete files of that. That's equivalent to -O, -D, and F for a force. So this does have a default retain days of 365, so it'll keep any backups it takes here for 365. But you could add the -R to give it 5 years or however many days you want. Okay, real quick, just showing some example batch programs. So you could use the bpx batch program to start a shell and then do a change directory and issue the hbackup program. And here's showing the hlist with recurse of the backups that we're taking. So if you wanted to just capture the output and what was currently as of that time, this would be a good way to do it. Some useful commands, the ZFS admin file info option. So if you want to find out some information about a particular file, you could use that. And here, the thing I want to just point out to you is this ref time field. So that is the field where HSM is storing the backup timestamp. So as we're taking backups of files, we're storing that last backup timestamp here. So that's the main thing we use to determine if a file has been backed up and whether or not it needs another backup. Of course, if the file is in a read-only mounted file system, then we can't update that, and therefore we can't use that, so we'll use the values in the HSM inventory. But that is a quick way to check what is, somebody backed this up at the last time. Another thing a lot of Unix users use is shell scripts. So this was one of the reasons that another reason why I introduced these Unix programs for HSM is that would allow you to use the shell script and other Unix tools to do something. So here, this very complex, weird looking kind of thing is showing something. What does this say? Okay, so this says do an HList with recurse of the $1 as the input for the shell script. So list all the backups for this this current directory, and then pipe that output into the grep program, searching for dir space equals, and then all the rest of this stuff, pipe it into the string editor and change the dir equals. So any line that starts with has dir equals in it. Change that to an H backup with operator mode, recurse cross mounts, verbose, changed only, and targeting tape. And this gobbledygook syntax is basically to the end of the line, and start that with send that to a no shell. So what this does is it says examine this particular directory for any new backups. So I've had some users that want to take backups of their auto mount file systems. So these are, the user directories. They're usually not mounted. So when HSM, if you just tell HSM to back up the /u directory and nothing's mounted, then HSM will say, I didn't find anything to back up. So the directories have to exist. But when HSM tries to reference those directories, if you tell HSM, here's a directory I want you to back up, then AutoMount will mount that file system, and then HSM can start working on it. So if you use this shell script and say HList-X of /u, then whatever backups HSM currently knows about, then it will create new commands to attempt a new backup or examination of each of those directories. So that'll cause those auto mounts to get mounted, and they will be processed for changed files. And if you're doing testing and you really want to delete a lot of backups at once, then you can also use this syntax to list all the backups for a thing and find any lines that have file equal and change that into an HB delete with -A. So this basically says, HSM, which backups do you have? And then turn each of that output into a HB delete command and delete those backups. Some queries that I often use, I query the active, query the backup, query waiting, and query user. See what's going on. As a user, I've issued a command and it's just kind of sitting there and not sure what's going on. I can do a query user on my user ID to see what's waiting and what's going on, and then I can use cancel to show that or to get rid of those. So last, before I get to some demo showing actual things, I just want to talk about some of the follow-on support that's still on our plate. We had a request to enhance expire backup volume and with a Unix path keyword, so you can target your expire backup volume processing to a specific file name or a directory subtree. So that came out in this OA60587. So that's part of the ZOS 2.5 base support. So start using it there. Another high thing for the other commands, not the Java program, but the Unix and TSO programs, is allowing exclude criteria in a file also, and so that's something we're working on. We have 3 current RFEs that people are very interested in. One is backup of files that are currently in use, so that would be notice that the file is in use and then just take a fuzzy backup of it. Don't try and don't just fail because you can't get serialization on it. Other one is CPU usage during expire backup volume processing. You bring that down. And then one customer was having fun with an empty directory that's a mount point. Sometimes the ZFS would be mounted and the backup request would be successful even though nothing had changed. But then if the ZFS wasn't mounted, then they'd get a failure message saying that empty directory is already backed up. So we're changing that. So I talked about the incremental backup enhancement and then support for these files in a read-only mounted ZFS. That changed HSM to be a little bit smarter about how it processes the files. So I wanted to show you really quick. So the file mode host, doesn't look like there's many messages there. So let me get down to DFSMShsm. So I have a DFSMShsm FM for my file mode host. So this is where I start up. It's basically the same started proc, but for my BCDS, MCDS, I have new names. And also for this one, I am running in a multi-cluster BCDS environment. So my backup control data set is spread across 4 different data sets. So some of the customers I've worked with, they've found the need to have multiple BCDS support, and also each of their individual BCDSs they define as a multi-volume VSAM. So perfectly fine. In here, there's nothing super special. The only thing I changed was I'm using the str option, which says go look in the parmlib arc str xx parmlib member for more starting information. And then in my classic host, did something similar, except I just was specific about str equals ds. And this one, I just converted my existing HSM for that. So let me go look at the parmlib. So here's my look at the strfm. So this is more startup parms for HSM. So here's I specified host type equals file, and the rname DSN equals yes, that's a required, and the CDSQ equals yes to the log switch. And if I look at the for the classic HSM, I just specified host type equals classic. And in my parmlib member, it basically just made a copy of my classic host, with the exception of, it does have a requirement that the Plex name must be different from your classic host. So let's see if I do have my file mode host running, so let me just shut it down. All right, so I can start up my classic host. Starts that guy. I'll start up my file mode host. So one of the things is there's the query command was updated, so I can do a fm query image. So if I do a query image, it will show me that I have one HSM host that is running in the classic mode, and I have another host that is running in the file mode. So this basically, if you have the multiple address space HSMs, then you would see auxiliaries and that kind of stuff there. Get out of this, get over to here, and yeah, you can just do hsend u. It'll show you the same information. Hsend would 2, and query on the startup. For the file mode host, I added a new thing that tells you what's the host type. So if I do an hsend query startup, so this is sending it to the classic host. You can see it says host type equals classic. So the default for host type is full. So all of you that haven't implemented this, you're running in a full HSM mode, full mode HSM, which supports both Unix files and datasets if you want to. And getting a little short on time, had some demos to run, but I thought I would show a little bit more of the Java program. So there's excluded files, unchanged files. So this is the detailed output mode. You can see there's a lot of that going on. And then every file that is then sent to HSM and successfully processed, it'll get back this ARC1000I message telling you about that. And oops, okay. And then there's those statistic messages about how many it was sent. And go look at OMBS. What did I want to show here? I think that's pretty good. Were there any questions in the chat? Okay.
No, there's no questions in the chat, but I will allow people to unmute themselves now. If anybody wishes to ask a question. I would have thought you've covered pretty well everything, Andrew, actually. That's very, very thorough.
Oh, great. Well, I appreciate you guys listening, and hopefully you have great success using all of this new support. Feedback I've received so far from so I did a ZOS function beta for this Java program, and so there was I think 8 or 9 customers that all got to try it out early on and give me feedback and change it before it became official. So that was very, very useful to have that input from people that actually use this stuff. So a lot of them were telling me with this Java program, they're now able to back up their entire system. So yeah, in the millions, tens of millions of files being examined, and hundreds of thousands of files being backed up, in a particular run, and all happening within their backup window for that day. So very exciting stuff for me.
Yeah, I think the file mode support is really good because it also touches the Java offload as well, which would be hugely popular. So
Yep.
yeah, great stuff. Nobody's asking any questions. As I say, I think that's because you've pretty well covered stuff. So I guess it only remains to thank you very much for such an excellent, detailed presentation. Would the participants be kind enough to do the session feedback I'll just paste a link in the chat, and I'll make sure I put the right session in rather than the previous one, which would confuse matters. Okay, give people a moment to click on that. But yeah, excellent. Thank you very much indeed, Andrew. Much appreciated.
Thank you all. My pleasure.